Hello.
Hello, can you hear me? Hi,
Hello.
can you hear me?
Audible?
Can you hear me?
Yes, yes, I can hear you.
Okay, so we will start our today's session.
Okay.
So
Recording in progress.
I share my screen. Can you see my screen?
Yes.
Okay. So hi and welcome to the third day training session for beginners to advanced courses on Google Earth Engine. So basically today is our third day and we already covered the first and second day, and I am course coordinator. Basically today I will try to show you that this is our course modules. First of all, I will try to discuss about that how you can easily filtering and displaying the Sentinel-2 satellite imagery, and we already covered the Landsat 8. Okay, so today first of all this is our full course content. Okay, for the 7 days we completed all of the things.
Hello.
Yeah,
We covered MODIS.
yeah, we covered the MODIS as well as also covered the Landsat top of atmospheric dataset.
Okay, okay.
Yeah.
Okay, so now we are moving to the next one. Is that what you're saying?
Yeah. So first of all, today this is our third day course content. First of all, I will try to discuss about the filtering and displaying the satellite image for the Sentinel-2 and monitoring from here the NDWI. Okay. Then discuss about the NDVI time series chart.
Okay. Just to mention here one thing. Hello.
Yeah, I hear you.
Yes, sir. Just 1 minute. I just wanted to mention one thing. The second day course, I haven't completed the whole of it. So I just studied little bit of it, which you had sent the video of.
Yeah.
So it's my request that in the fourth class, I might clarify little bit of doubts from the second class. So hope that is okay with you.
Okay, no problem. No problem. Okay, if you have any doubt or any,
Okay.
you can just ask
Yeah.
me. Then I will try to help you. And if you want, you
Yes,
can also
sure.
share your own screen and ask me the problem. Okay, no problem.
Yes. And the one that mail which you had sent to me, I need a little bit of clarification on the use of metadata and all. I couldn't follow it.
Yeah.
So it would be good if we can discuss that as well.
Okay.
Yeah.
Okay. So this is our course content for today. So then
Yeah.
I also try to export any shapefile from the Google Earth Engine.
Okay.
Suppose you want to make the shapefile for any river or any other shapefile, we can just export digitizing our shapefile. Then we can easily export this shapefile from Google Earth Engine platform. Then calculating any indices from satellite images. Mainly in this time here I try to show you that all of the band calculation. Suppose you want to make the Landcover, suppose you want to make the NDVI using the Landsat 8 images. You need to select it here the two band near and red. Then you just calculate these indices in here. Okay, so in this time I also try to show you that so that you can easily calculate it any indices. Okay, then I also try to show you that how to add the legend. So mainly in this time I will try to show you the gradient legend. Okay, and other type of legend we also cover the another next classes. And then I also try to show you the LST monitoring. So mainly we can monitor the LST in the two satellite data, MODIS as well as Landsat. In this time I will try to show you the MODIS satellite dataset, and I also try to show you that how you can easily make the time series chart of the LST monitoring in here. Okay, so basically, and then I also try to show you the calculated the NDWI from MODIS and as well as Landsat data. Okay, so basically this is our third day course content, and we will move to one by one and practically show you that all of the things. Okay, So first of all, filtering and visualizing satellite images in Google Earth Engine platform, and we already discussed about our the second class when you filter our Landsat satellite images. We can also focus the same way in here, because when you filter any satellite images, you need to filter some factor. Suppose you need this sentinel images for a specific region, and this is the one way for filtering. Okay, suppose you want to need for the images for any specific properties. Suppose you want to set in the previous class we also tried to show you that we can get only for those images whose image will not be more than 1% cloud cover. Okay, so this is the one factor for the filtering the filter metadata or image properties. And another factor is that you suppose you want to need these images only for the year of 2017 or other period of time. Okay, so this is the another factor for the time. So mainly in this time when you move to the Sentinel-2 images filtering, so we will follow this all of this step. Okay, so suppose if you want to need this Sentinel image for the Dhaka city, so this is the one factor for the filtering the satellite images for the specific region. Then if you want to need this image cover, cloud cover not more than 1% cloud cover, so this is the another factor for filtering your image properties or filter metadata. And you only want to this images which image for the year of 2017 or other period of images. Okay, so mainly these three factor will need when you filter any satellite images. So whatever Landsat or Sentinel, we just follow this step one by one. Okay, so now I will try to go to my code editor and try to show you that practically so that you can easily do it. So I simply open my code editor in here. So this is I open a new code editor. So in this time I use here the Sentinel-2 satellite imagery. I simply search here this data set in here. I simply click on the browse data catalog. When I simply click to here, you can see, okay, you can see here the different types of data. I simply click on the Sentinel. Okay, and in Sentinel we can get the different types of satellite images. So here the network connection is not good, so that's why it takes some time. So it will appear it. So here you can see Sentinel-1, Sentinel-2 multi-spec. I simply click on the Sentinel multi-spectral instrument. So here I can get the two product. First product is the surface reflectance, and another product is the top of atmospheric reflectance. Okay, so I simply use this data set. So I simply click here. Okay, so here I can get all of the information about this Sentinel-2 multispectral instrument level 1C. Here you can see this dataset availability date. It will be start from the 2015 and presented. It will be available, and it will be dataset provided is the European Union. Okay, Copernicus, and you can see this is the collection snippet. Okay, in this dataset. So you can also see here the different types of band with their scale and the resolution. Okay, so in this time I just simply copy this collection, simply copy. Okay, and then simply paste in my code editor. So here you can see, and then I just simply use a variable. I simply call this variable is that Sentinel-2. Okay, so here you can see this image will be imported. Okay, so this satellite image will be imported in my code editor, and here I give this variable name is that Sentinel. Okay, so now you can see when my cursor I put on this code, you can see if you want you can convert to an import record. Okay, so in this time when I simply click on the convert, you can see it will be import. Okay, but it's not mandatory. But when you work with, simply search the go in here dataset and click to import, we can get this like this, okay, like this code, line of this code, okay. So we can also do for when you just copy your collection snippet and paste in your code editor and give a variable name, then you can simply your cursor on this code of this line code, and then you can see convert, okay, simply click to the convert, then you can get this, okay. So you can see I just simply imported my image collection. After this, I want to get this image. Suppose I want to get this image for Dhaka city, okay, so or Dhaka district. I simply use here my shapefile. So here I already show you that how you can easily import your shapefile. In this time I simply use this shapefile, okay. This is our boundary shapefile, and I want to get this sentinel images for here for this area, okay. So I simply click to import. This dataset will be imported. As default variable name is the table, I simply put here the Dhaka, okay. You can say I put this variable name Dhaka. So now I want to filter these images. So we already know that suppose you want to filter this whole collection, how many sentinel-2 image will be available here, we can check it easily using the print function, okay. Then I want to, suppose if you want to check this, I simply use here the suppose print, then I simply use here the sentinel, and I already discussed all of this part in when I filtered the Landsat images, okay. I simply use here the size, you can say simply click to the run. So now I can get the whole collection of the Sentinel-2 multispectral instrument for the whole world between this time frame, between this year of 2015 to present time, okay. So it will be computing. We can get the large collection from here, okay. So then we need to filter this large collection using our specific region, or using our specific image properties, or using our specific time frame, okay. So now I will just do it. So suppose in this time we can get the large collection in here, and now I want to filter it using my boundary of Dhaka city. So now I want to filter this whole collection. From this whole collection I need only for those images which image will be straight in Dhaka city boundary, okay. So for this I simply take a variable. Suppose I give this variable name is the image. I simply use the image dry. You can use any variable name. Suppose I want to from this in this time, suppose I want to get this sentinel image for the dry season of Bangladesh. So I simply put here the image dry. You can use here the any variable name in this here. Then I simply call my whole collection sentinel 2, and then I simply use here the function, this function called the filter bounds, okay. And I use here the filter bounds. I want to get only for those images which image will intersecting with my region of Dhaka city boundary, okay. So that's why I simply use here the filter bounds. So mainly filter bounds in this function intersecting with your whole collection Sentinel-2, intersecting with your region of interest. In this time my region of interest variable name is Dhaka. I simply put here the Dhaka, okay. So now I want to check how many images will be available here. You can just put here the print, then use the size, okay. You can see it will be reduces, okay. So then suppose we already know that we can also, suppose in this time from this image I want to need only for the image for my dry season, okay. So in this time I simply put here my dry season date. So I simply use here the filter, then date, okay. Then I put here only for the dry season image date. Suppose I want to calculate it here the dry season image for the year of 2020. Just I simply put here the 2020, then simply use here the 1st January. It will be start from 1st January, and it will be in for the 2020 April suppose 30. So this is my dry season. I simply put here my this date. Okay, and then, and we already know that when you work with the image properties, we can get the different types of image properties from this Sentinel-2 image data collection. I simply you can image properties. Here we can get the use the different types of image properties which you need. Okay, so in this time I want to work with these image properties for the cloud pixel percentage. Okay, and you can also use the cloud coverage assessment. So in this time I want to add here the cloud pixel percentage. So I want to get from here the minimum. So from this time period, you can see I use this time period. From this time period I want to get from here the minimum pixel of cloud. Okay, so for this we can, if you want, you can use here the filter metadata function. Suppose you can use here the filter metadata function, and we already work with this. Okay, filter metadata function. Then we can use here the three argument. You can see name, then operator, and then value. So in this time my name is my image. This is the cloud pixel percentage. Suppose I want to get the cloud pixel percentage less than 1%. Okay, I simply use the 1%. So this is the one way for filtering your image, specific image properties. Okay, and it has the another function, this function called the sort. So I want to use here the sort function instead of the filter metadata function. Okay, so I simply commenting this line, and then I simply use here the dot notation and use here the sort. Sort is the function, it elements of the array along one axis. Okay, so I simply want to get put here my image properties. Suppose my image properties is that like that cloud pixel percentage, and then I simply use a function, this function called the false. So it means that from this time period I can get here the automatically minimum pixel cloud pixel from this. Okay, so it will be sorting like this. So I use here the false function, and then I simply use here the cloud pixel percentage. So my image I want to get from this image, which image will be minimum pixel percentage. Okay, and if you want to, you can just put here the random number. Suppose you want to need for this image cloud pixel percentage 1% or 2%, then you can simply use here the filter metadata function. Okay, and then I simply use here the mosaic. So mosaic is a function in Google Earth Engine platform. So it is the another, you can see I simply use here the control backspace. So okay, I will simply search on the docs what is mosaic. You can see, so mosaic, you can see mosaic composites all the images in collection. So it composite all the image in a collection using the max function. So I simply use here this mosaic so that it composite with, suppose from this time period I want to get here the 10 images. So it get that all images in a collection, in a one collection. So when I use this mosaic function, so suppose in this time between this time period I want to get from here the 10 images for the Dhaka city or Dhaka district. So now it will be mosaic. Mosaic means that it will be make a one composite all the images in a collection. Okay, and then suppose and I want to clip it with my shapefile. So I simply use here the clip function. Okay, then I simply clip with my geometry name is the Dhaka. I simply put here the Dhaka.
Sir, just interrupting here.
Yeah.
What is the use of the mosaic?
Yeah. So this mosaic, I simply use here the mosaic function because suppose in this time here I can get from the 10 images. Okay. So
Mm-hmm.
this 10 image will be take all of the composite, okay, then it will make a one collection. So only one image I can get from here. All of the image take, you can see, composite all the images in a collection. So it make a collection, composite all from the all of the images. Suppose I can get from here the 10 images, so it will be composite all of the collection in a one collection, and I can get from here the one image, but it will be produce this image from all of the images, okay, where how much image I can get from here. So it will be take all of the images for composite it, okay.
Okay, okay. And
And
another is for
before
the
here
true
I
and false.
use the median or mean or max or other function, then it will showing only for the result of this pixel value. Suppose when I use the mean, then it will be showing the between this image, get all of the pixel value, average pixel value, and produce a one image from this mean result, okay. Suppose in here I can get here the 10 images, so it can calculate it all of the 10 images mean result, then I can get here a image, okay. But when I use the mosaic, so it composites all the images in a collection, okay.
Okay. And another one is the reason you told for using the false and true. Can you repeat it once?
I don't understand.
The dot sort function,
Yeah,
that one.
so
So there you said about using the comma false, that
okay,
part.
so this is the
Yeah.
another way. So for filtering, suppose in this time I don't know what is the minimum pixel, I don't know what is the minimum pixel, cloud pixel in this between this time period. Suppose I can get here the total 10 images, and I don't know what is the minimum pixel, cloud pixel result in here. So I randomly put here the 1, okay, but I can get here the also minimum, suppose 0.5, okay. So that's why I this result I did not understand, but when I use here the cloud pixel percentage then false, then it automatically calculated, it automatically give me here the minimum cloud pixel image, okay. So it I just put here the 1. So in this time here I can get only for those images whose image will not be more than 1% cloud cover, but I want to the minimum cloud pixel percentage minimum, and this minimum result I don't know, it will be 1 or 0.5 or other. So that's why I simply use call my image properties cloud pixel percentage, then simply put here the false. So then now it will be sorting my image as like this. So it will give my this image whose image cloud pixel percentage is minimum, okay.
Okay, okay.
So now I want to show this result in map add layer view. I simply use here the map dot add layer function, and this is our image object. I simply put here, okay, and you can see I simply focus on my center of boundary. I simply use here the map dot center object function, and then I simply use here my shapefile name. Suppose my shapefile is that Dhaka, and zoom level I can put 10. I simply click to the run. So I can get this image for the Dhaka city in here, okay. I can totally get the black, okay. So now you can see I get this black image because I did not add any visualization parameter in here, okay. So that's why it looks like that, okay. So now I want to add here the visualization parameter, and we can easily do it. We already know that about the spec. I can simply click on here, and suppose I want to show here the two color composite. I simply use here the B4 red, V3 green, and B2 blue. Then I also increase the stress 98%. Then simply click to the apply. So now we can see I can get this image, okay, for the Sentinel-2 image will be available here. And now I can use this image for the different types of remote sensing work, like that's NDWI, NDVI, then Landcover classification, and other work we can easily perform using this image. And you can see here this image, there is no cloud because this is a dry season, okay. But when I want to take this image for the wet season, you can see here I can get some cloud, okay. So you can see there is this image is the very clear, you can get here. And now I want to import this visualization parameter in my code editor, so that's why I simply click to the import. You can see a new line of code will be added here. Then I simply copy this visualization parameter and I simply use here this variable name, and I simply give this layer name is the true color, okay. No, I simply put this is the dry season image, so I mean dry image, okay. I just put this one. So now we can see I can get here the dry season image, okay. And you can see there is the no cloud will be available here, and we can get the very clear image, and this resolution is very high because this is Sentinel-2 satellite imagery, and we can easily understand any feature or the cropland or other feature we can easily identify using these images in here, okay. And now if you want, you can easily export these images, and we already discussed about this. And suppose in this time you can see there is the no cloud, but when I work with the wet season, you can see some specific cloud will be available here. So I will try to show you that. So for this I simply copy this whole of this code, okay. I simply copy and then I simply paste here, okay. And now I just change here this date. I simply put here the wet season date. For Bangladesh purpose, I simply use here the wet season is the, it will be start from January, February, March, April, May, June. I simply put here the June, 1st June from October. I simply put here the October, okay. Wet season date, I simply put here the wet season. And I also change this image variable name. Suppose in this time this is the image for wet season, I simply copied this wet season and paste here. After this you can see here I simply change the layer name. So in this time I gave this layer name is the wet season, okay. So then click to the run. So now I can get here the two satellite images. First is for that dry season, second is for the wet season. But the dry season is the no cloud, but wet season has some cloud. We can FAR it in here. So here network connection is very bad, so that's why it takes some time for FARing, okay. Okay, to be FAR, right? Okay. Okay, so you can see this is the dry season of the satellite images. You can see here there are the different cloud in here. You can see this cloud, there are the lot of cloud will be available here, okay. You can also see this cloud, this cloud, this cloud, this cloud, okay. And you can see there is a lot of the water bodies in here, okay. This is the water in the season in here. So in this time, this is the problem when you work with this the cloud image for making the any remote sensing work, okay. So that's why we also need to remove the cloud from these images, okay. And we also covered this part for removing the cloud from the satellite images in our another classes. So this is the another big code for when you removing the cloud. Just I will try to show you that, but this cloud we can easily remove using the cloud max function, okay. So we can easily remove it. So you can see when you work with the any place for the wet season, you can see that the sum of the cloud will be available here. So we can just easily remove all of this cloud using the our cloud max function in Google Earth Engine platform, and we can work with the satellite images, okay. So you can see I simply I try to show you that how you can easily filter and how you can easily display this result. And you can see here this is the two images will be available here. Dry season there is the no cloud, but wet season has a cloud, okay. But we can easily remove this cloud from here, okay. So in this time in this code, if you have any question, you can ask me any question or any doubt.
No question.
Okay. So now you can see I just created this image in here, and supposing this time I want to try to show you that how you can easily make a simple project work for the NDWI for identify the surface of this water, okay. So NDWI mainly work for the normalized difference water index, and it is indicating the surface of the water, so where the surface water include. So now in this time I will try to show you that in the satellite images I want to monitor where the water will be available, and I simply use here the NDWI, okay. So I will try to, and I will comparing this result with in dry season and wet season. And wet season you can see that the different lot of the place will be water surface, we can easily identify it. And dry season we can also say there is the no other water body like from except river, okay, we cannot find it, okay. So try to start this part. So for this you need to work with, suppose in this time I want to calculate the NDWI, okay, from here. And we already know that when you work with NDWI we need to two band. So simply we need to work with the two band. When you work with the NDWI, this band is that green and near, okay. So this is the green and near band. So in this time I simply write this equation. So I make a line of this comment. I simply put the NDWI equation, and this is our NDWI equation. For that I simply put here the our equation is that green band subtract with near infrared band, okay. I just simply put here, and it will be divided by sum of the two band, green plus near, okay. So mainly this is our equation, and now I want to make this equation and determine the NDWI in my code editor, okay. So now I want to just, and we can make these indices in the different way, and I also provide you this lecture for another slide. But in this time here I use the A1 function. So that function is automatically generate these indices, okay. So wait a minute, I have a message in my WhatsApp, I will check it and send it, okay. Wait a minute.